Hey everyone, Nariman here. Welcome to my channel. Today I want to share with you a few key techniques to improve your RAG's accuracy. I'm gonna use the code base that I wrote for chatting with PDF using Deepseek and LangChain, and I will try to add these new techniques on top of this RAG. So if you haven't watched that video, or you have no idea on how to set up a very basic RAG with LLMs, I would strongly suggest that you watch that video. I'm gonna put it up there, and then you can come back and watch this one. So this is our code base. It's pretty simple. We are uploading a PDF, and then we are extracting all the text from it using PDF Plumber. Then we will split the text into chunks because LLMs are not that great with long text. Then we are indexing it inside the vector store, which means that we are using an embedding to convert all these text to vector and then storing them. And then user is going to ask a question. We will pass this query to our vector store and retrieve all the related documents. And then we will pass the user's query with all this context to the LLM. And we are asking it, okay, can you answer me this question with the context that I'm providing to you? So this is basically what every RAG is doing. But there is a thing. Many people, when they first set up their RAG and they provide their knowledge base to the LLMs, they are complaining that they are experiencing poor results. So they are asking some basic questions about their documents, and it seems like LLM cannot answer that. The main reason is your retrieval strategy. So many of these RAGs are using semantic search. As you can see, we are also using the similarity search here. These vector search methods are very good in capturing the semantic and the relationship between the words. But sometimes they miss very crucial exact matches. Why? I can show you an example. Let's say we have like two documents. Let's say there is doc 1 and we have like something like Queen of England and then some other text in this doc. And then in the second doc, we have something like King of Jordan and then something else. So we have these two documents, and then we are asking a very basic questions about the queen. So when you are asking about some word like queen, you don't expect the document that has the word king in it will be retrieved. But that is not the case with the similarity search. In the vector space, the words queen and king are very similar to each other. Also, the words England and Jordan. So in the vector space, queen and king will match, England and Jordan will match. And when you are trying to search for something like queen, there is a high chance that the document that contains the word king would also be retrieved. So then you are providing your LLM with the wrong context. So this is where you can improve. You need to make your retrieval method much better than just a simple similarity search. But first, I want to explore some other easy solutions as well. Let's say you are using semantic search and you are experiencing poor results. You don't need to jump straight to fixing your retrieval method. First, you can explore some easier solutions. So ask yourself first, how big is my knowledge base? Modern day LLMs has much bigger token limits. So for ChatGPT, for example, you can pass around 128,000 tokens. For Claude, you can pass around 200K tokens. Even on your local models on Ollama, there is a command that you can set the max token limit and you can increase it to something around 128K. So approximately you can pass around 500 pages of PDF in your prompt. So it's not a small number. So if you have a very small PDF, you don't need to split it in different chunks and then store it inside the vector store and then retrieve only the related documents. You can just pass it in every prompt. Of course, you are gonna pay more if you are using Claude or ChatGPT or Gemini because you are sending more tokens, but that can also be handled with things like prompt caching. So this is our first solution. Of course, it's very simple, but it would more or less solve your problem. The second approach that I want to offer you is to play with the chunks. So you can see that when we are splitting the text, we are passing some stuff like chunk size, chunk overlap. So play around with them. For example, it's recommended that chunk size shouldn't be anything more than a couple of hundred. So if, for example, in this case, we have 1000, maybe try 500 and then see if the results are getting any better. So this is also a very simple approach that sometimes can work for you. But in most of the scenarios, you need a much more complex approach. And as I told you, it's gonna be fixing your retrieval. So I explained it to you that how semantic search can lose exact matches and retrieve some unrelated documents to your query. But there is a much older approach on retrieving documents, which is called BM25 or Best Matching 25. Almost all modern day search engines are using this approach, at least at the core of their search. For example, the default retrieval behavior of Elasticsearch is BM25. So in contrast with the semantic search, which captures the meaning and relations between the words, BM25 will only match the tokens in your query with the tokens inside the document. So if you go back to our example of queen and king, if you search something about the queen, it will go over through these docs and says, okay, I'm seeing queen here. So I'm gonna retrieve this one, but I'm not seeing queen in this document. And of course, I don't know anything about the meaning of these words and the relation between them. So I wouldn't retrieve this second document. So you can see that BM25 approach and semantic search approach somehow can complete each other. There are some cases that BM25 cannot retrieve, and there are some cases that semantic search cannot retrieve. So if we find a way to retrieve both from BM25 approach and semantic approach, and then combine the result and remove the duplicates, and then pass this to the LLM, we can get much better results. So this is my suggestion to improve your RAG accuracy, to have some kind of hybrid retrieval approach. And luckily we can do this more or less easy with LangChain framework. So we are gonna create two retrievers, one called BM25 retriever, the other one called vector retriever or semantic retriever. And then there is a class called ensemble retriever in LangChain that takes these two, and for each of these you can define a weight on how much do you want to weigh the result of each retrieval method. And then this retrieval will combine the results for you based on the weights that you gave them. So let's go ahead and change our code this way. So when we are creating our index in this method, index docs, I'm gonna change this to be build semantic retriever. I can go ahead and even define this vector store and embedding inside this method because I'm not gonna use that outside anymore. And then when I indexed all my documents inside the vector store, I'm gonna return this vector store as a retriever, like this. And then I'm gonna also create another method, which is called BM25 retriever. And here, I'm gonna get the documents and then create a retriever from these documents. And that would be it. I can just return this. So this BM25 retriever is one class inside LangChain that uses the approach that I mentioned to retrieve the documents. You should also pay attention that pre-processing the text is very important to improve the accuracy of BM25. For example, tokenizing, normalizing the words, also stemming. So you can pass pre-process function to this retriever to improve the accuracy. I'm gonna give the word tokenize method from the NLTK, which is a famous NLP framework, to pre-process my documents before indexing them. But you can go ahead and define your own pre-process function, which can be more complicated. So now that we have these two methods, when we have our chunk documents, I'm gonna index them in both and get them as retriever. So here is the semantic retriever, and here will be our BM25 retriever. Now that I have these two, I'm gonna combine them using the ensemble retriever. So I'm gonna create an ensemble retriever. It's gonna get retrievers as a list, and it's gonna be the semantic retriever and the BM25 retriever. And then you can give your weights. I'm gonna give half a point each. So I'm gonna give them like equal weights. But here is another point of improvement. For example, you can give them different weights and see which result is best for you. But for now, I'm gonna just keep it like this. I'm gonna also name it like, I don't know, hybrid retriever. Then I also don't need this retrieve docs method here. I have my retriever here. So you can invoke this with the question, and that will be it. So just to go over the process one more time so you can get it better, I'm gonna ask the user to upload a file. I'm gonna upload it. I'm gonna extract the text from it. I'm gonna chunk it in a smaller documents. Then I'm gonna give it to two different retrievers. I'm gonna index it both as vectors in a semantic search manner, and I'm gonna also index it in classical search engine way, and then I'm gonna retrieve them with BM25 approach. And to combine the results, let me also break it down here so you can see better. I'm gonna use an ensemble retriever in LangChain, which allows us to give each retriever some weight and then combine all the results together. Then when the user asks a question about our documents, I'm gonna pass this to the hybrid retriever here, get all the related documents, and then I'm gonna ask our LLM that, okay, this is the user question, this is the context, and this is my prompt. Please answer the user's question with the context that I'm providing to you. That's it. Let's go and run it. Let's go to the command line. I'm gonna say Streamlit run hybrid retrieval rag hybrid pdf rag.py. This is our file. I'm gonna run it, and then let's go to the browser. Yeah, you can see our application. I'm gonna go ahead and again upload this Declaration of Human Rights as I did in the previous video. We need to wait a little bit so it is indexed properly. Yeah, as you can see, when the PDF is uploaded and indexed properly, now we can ask our questions in this chat box. Let's just ask, what is Article 2 about? And as you can see, the answer is pretty accurate. This part is about thinking, but the answer is that everyone is entitled to the rights regardless of their race, sex, religion, or other factors. And if you have a look at the Declaration of Human Rights, you can see that Article 2 is exactly about this. So I would suggest you implement this hybrid approach and see if it is actually improving your RAG accuracy or not. It should improve it a lot, but even if you are still not that happy with the results, I have another approach for you. There is a method also called contextual retrieval. There is this amazing article on Anthropic website. Let me just copy this and paste it here. Yeah, this one, which I will also put it in the description of this video. I would encourage you to read the whole article, but I will tell you what is it about. Imagine that you have a knowledge base full of like financial reports of different companies. Then you are asking like, what is the revenue of like this year for Apple? When you chunked your financial report for Apple and also for other companies, there is a page inside your documents that have this information for Apple, but you are losing the complete context here. It should be very hard for your retrieval method to understand this piece of text was for Apple's financial report and not for other companies, especially when you are making smaller and smaller chunks. So you are losing context. And what this article is actually suggesting, and they are saying that it is improving RAG accuracy a lot, is that they made a very small prompt here. And when they are doing the chunking, every time they are asking the LLM that, okay, here is the whole document and this is our chunk. Give us a very short context about this chunk related to the whole document. And then you will get a very small paragraph of the context from the LLM, and they will append this context to the chunk and then store the whole text. So now every chunk has this small context attached to it. This will improve the retrieval much better than simple semantic search or even hybrid search. Of course, one thing to notice is that it will make your index time much longer, because every time that you are chunking, for each chunk you are making a call to your LLM and asking for the context. So this is also something that worth mentioning and can help you a lot. I know that some other frameworks like Llama Index has an implementation for this approach, but it's also very easy to implement it in LangChain. You just need to change the method that is splitting the text. So I encourage you to read this article, and if the approaches that I suggested before is not working for you, also try this one. I hope you enjoyed watching this video. Please like this video and also subscribe me for more content like this. See you around.